Hey there. Ever wonder how your phone learns to recognize your voice without sending your recordings to a server? Or how hospitals could collaborate on cancer research without sharing patient files? That's the power of federated learning, a way for AI systems to learn from data without ever seeing the raw details. But here's the catch. What if some data sources are wildly different from others? Like a group project where one student has all the answers and another has none. How do you make sure everyone contributes fairly? This research tackles that exact problem. Think of federated learning like a team of chefs cooking a meal together. Each chef has their own ingredients data, but they can't share them directly. Instead, they each make a version of the dish, then swap notes to improve the recipe. But here's the problem. If one chef's ingredients are totally different, say they're using a rare spice no one else has, their version of the dish might not fit the rest. This data diversity can slow things down or make the final meal worse. So how do you fix that? The researchers designed a system that incentivizes participants to contribute their best data. They didn't just assume everyone would play fair. They built a reward system that measures how valuable each person's data is. But how do you even measure that? Enter the Wasserstein distance, a mathematical tool that compares how different two datasets are. Imagine comparing two recipes. One uses a mix of exotic spices, the other is super basic. The Wasserstein distance would tell you how far apart those recipes are. By using this, the system can figure out which data sources are truly unique and valuable. Here's where it gets clever. They turn this into a game theory problem. Think of it like a negotiation. The system, the learner, sets rules to encourage honest participation, while each participant, or agent, adjusts their strategy to maximize their rewards. It's like a classroom where students get points for honest work. No cheating, no slacking. If you contribute high-quality data, you earn more points. If you try to game the system, the rules catch you. Their experiments show this works. By combining the Wasserstein distance with a peer prediction system, where participants' contributions are compared to others, they created a framework where everyone has an incentive to share their best data. The result? Faster, more accurate models, and no one can cheat the system. It's like giving the team a recipe that adapts to every chef's unique ingredients. But here's the math behind it. They used Lipschitz continuity to ensure model updates don't jump around too much. Think of it as a speed limit for AI, preventing wild swings when one device's data is extreme. They also applied the triangle inequality to measure how much models diverge across devices, weighted by data contribution. This lets them predict worst-case scenarios and build safety nets to keep the system stable. So why does this matter? As AI becomes more part of our lives, whether in healthcare, smart devices, or beyond, we need systems that work together without compromising privacy or fairness. This research is a big step toward making that possible. Next time you use a feature powered by AI, remember, behind the scenes, scientists are working to keep the system fair and efficient. Thanks for watching, stay curious, and let's solve the next AI mystery together.